Well, I'd like to start things off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, a college professor, or an industrial trainer teaching programming skills required in manufacturing, if you're a company looking for ways to demonstrate your software-based solutions, or even if you're just someone looking for ways to make IoT-related concepts easier to understand to employees or to customers, in any of these cases, I believe this presentation will offer some important options for you to consider. First off, we're going to start with the skills gap. Now, if you've attended any of our other fischertechnik education webinars, you've probably heard me discuss the importance of STEM education. STEM, of course, is the acronym for science, technology, engineering, and mathematics, and it should go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions that we're going to be looking at in this presentation, let's just stop and consider that last skill area I just mentioned, which is that of being a PLC programmer. Now, first off, for anyone who may not be familiar, let me just explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. Essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes which are typically found in an industrial setting, such as an automated manufacturing plant. As the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. And to get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, I took a look at a list of current job openings for PLC programmers on nuvu.com, and this would have been for the week of February 27th, 2020, just before the pandemic hit. Now, the listings at that time showed 15 positions being advertised with salaries of over $75,000, and 2 of which listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. At the same time as this workforce of tomorrow is getting their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering these programs. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed on the screen here, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, many other options available, things like high school CTE, career and technical education programs, adult continuing ed programs, vocational training, technical training and trade schools, and employer-sponsored incumbent worker training programs, as I mentioned before. Now, that all being said, the question that still arises for the educator, and that's whether you're in the university or the vocational school classroom, is how do you go about teaching PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and hands-on? But of course, there are also other areas to focus on beyond programming that require solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be that you're a company involved in creating or marketing a new type of software-based solution, and you're looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's even a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and of course there are more, there's a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled, small-scale models, which are designed to replicate, both in appearance and function, various automated robotic machines and systems which are commonly used in commercial manufacturing. Now, before we begin to look at each of these models, let me provide you with just a little bit of background on what fischertechnik is and what it's all about. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years based around their unique building system. Now, what makes the fischertechnik building system unique is that unlike other popular construction systems where the components are designed to simply stack, fischertechnik was created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help you to address very specific design needs. The fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, and he was also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik building sets, whether those that are intended for the retail market or intended for classroom use, has always been on helping to foster an understanding of technology and how things work. Many of the products offered by fischertechnik for the education sector are subject-specific sets focusing on different STEM-related areas, and these would commonly be things like mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik building system, and then they're asked to perform various experiments which allow them to explore and understand different aspects of the given subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria being put forth in a series of real-world scenarios throughout the curriculum. And these real-world scenarios are all going to be based around a lot of trial and error experimentation and research and things like this that the students are going to have to do. The line of fischertechnik simulation solutions, which is of course what we're looking at today, are something much different. The line consists not of kits, but again, these are a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Models found in the fischertechnik simulation line will include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. Now, this model consists of 4 individual workstations, including a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with oven, and a sorting line with color detection, all of which are designed to work together as one self-contained material cycle. Now, before we look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using fischertechnik solutions. Now, I will apologize in advance as the first few points are things I've touched upon before, but I think in each case it is worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, and this is again both in appearance and function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop size, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next advantage is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each of these models is available in a 24-volt version designed for use with an industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you prefer Siemens controllers, or if you would rather work with controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or of course many others. In any case, you can control these 24-volt versions with the PLC that you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language, such as the ones you see listed on the screen now. Please note that with these 24-volt versions, though, no PLC is included, and all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users, or for those teaching and exploring industrial processes involving PLC programming. In addition, for non-industrial users and for those educators who are not versed in or familiar with PLC programming, there are several models which are also available in 9-volt variations. These 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller. And each of these controllers is pre-programmed using fischertechnik's own RoboPro graphic programming software. The only additional component required with these 9-volt versions will be the addition of one or more 120-volt power adapters, as will be specified with each model we're going to discuss. Otherwise, in most cases, these models should be essentially ready to use right out of the box. Moving right along, if you're involved in demonstrating or exploring IoT, what we also call the Internet of Things, besides the fact that many end users have adopted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard. We will, of course, discuss this in more detail a bit later in the presentation. Oh, we skipped one. It's going backwards. Finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look at any of the other hardware-based industrial simulation solutions which are available in the marketplace, you've probably noticed that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of this price. as well as, again, being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's get started and take a look at each of the models which are available. The first model we're going to look at is the vacuum gripper robot. We'll get the video started here. Now, as you're going to see, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component you'll see in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of only about 7 pounds. The 24-volt versions of this model, as well as all of the first 5 24-volt models that we're going to be looking at today, each have a relay board for motor polarity reversal and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as all of the 24-volt versions, will require you to provide the PLC and the programming. Now, for a limited time, there is a 9-volt version of this model available, which is the version you'll see used in the video here, which once again comes pre-wired to the fischertechnik Robotics TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. And I will mention that for this and all the other models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next model we're going to look at is the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each piece. I will mention that this particular model is a favorite among educators I've spoken with who teach programming. And the reason for that is because it gives you a lot to work with in regards to the movement of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step of which will, of course, require its very own specific coding. The dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and program. A limited edition 9-volt version is also available at this time, which again is pre-wired to a pre-programmed Robotics TXT controller, and one 120-volt power adapter is required with that. The next model we're looking at is the multi-processing station with the oven. This model features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit, which includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard version of the model is a 24-volt version for use with the PLC of your choice, which once again has a relay board for motor polarity reversal and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. The limited edition 9-volt version in this case is connected to 2 Robotics TXT controllers. So in this case, 2 120-volt power adapters will be required for all operation in addition to what comes in the box. We'll just let them finish up with these last pieces. So moving right along, our next model, of course, will be the sorting line with color detection. This simulation features a system for detecting work pieces of different colors, and it sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has a relay board for motor polarity reversal, and both the multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you need to provide the PLC and the programming. The limited edition 9-volt version again comes pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter is required. And there we go. The next model is the factory simulation, and this combines the 4 models we've just reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection, all again combined into one self-contained material cycle. The cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with oven. After the work piece has been processed by this machine, it is then sorted by color in the sorting line with color detection, before being again moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these models previously, I won't belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one cycle, it will have a much larger footprint of approximately 39 by 31 by 16 inches. And in this case, the total weight is between 43 and 46 pounds, depending on what version you were talking about, the 24 or the 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. Usually we're pretty good on this, but like I said, they do tend to be very popular and in very high demand. A few other things to note. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt version. Now, in the instance, the 9-volt version is wired to 5 robotics TXT controllers, but because of the way it's daisy-chained, it's going to require 3 120-volt power adapters. As always, the 24-volt version will require the end user to provide all PLCs and programming and any other hardware required. Again, each station of the 24-volt version has a relay board for motor polarity reversal and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there's a storage option available for those users of either of the 2 factory simulation models we just discussed, the 9-volt or the 24-volt version, who might be looking for a way to, who might have to transport the model or just want to protect it when it's not in use. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and still be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds on its own. So please note that even when using the travel case, these models will still need to be shipped flat and stored flat. Moving right along, the next model we're going to look at is a basic conveyor belt. Now, this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyor belts can easily be connected to increase the length of transport as may be desired. Components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just under 2 pounds. Now, as previously stated, the standard 24-volt variation includes a multi-pin connector, but in this case, it's going to be 26 pins with the 2.54 millimeter grid. And that's the version you see here. And for a limited time, we also offer 9-volt versions pre-wired to the robotics TXT controller as shown here. One 120-volt power adapter is required for operation of the 9-volt version. The next model is a variation of the conveyor belt, which includes the punching machine. This features essentially the exact same conveyors we just looked at, except this time with a machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of about 3.5 pounds. Again, this is available in the standard 24-volt variation with a 26-pin connector and a 2.54 millimeter grid, as shown here. And for a limited time, we will be offering a 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the index line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station, along with 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions of this model are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in both the 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with PLC, as is shown here, and in a limited release 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Next model we're going to look at is a variation on the idea of a pick-and-place robot, in this case the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And again, this comes in either a 24-volt version with a 26-pin connector and 2.54 millimeter grid, designed for use with the PLC and programming of your choice, as is shown here, or also a 9-volt version, which in this case is not a limited availability model. It's a standard model, and it comes pre-wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter for operation. Now that concludes our look at the first 9 variations of simulation models. The next pair of simulation models we're going to focus on are designed to basically demonstrate and explore the area of IoT, and these are designed specifically for teaching about cloud-based monitoring and control. These 2 models go by the name of Training Factory Industry 4.0, and these are again available in both a 24-volt version for use with PLCs and 9-volt variations for classroom and demonstration purposes. Now, they've been designed to help address how the recent changes in industrial production driven by digitization have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, of which we looked at earlier, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of how the factory works and goes over a lot of the details, I'm going to step back for a moment and allow you to watch and listen to the narrator. So again, taking over the reins here, the following topics can be addressed with the fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production, lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, this model incorporates many features not found in the models we've previously discussed, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the models. Some other examples would be the camera used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, which enables the positions of each workpiece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. Now, as there are two variations of this model, let's go over what makes them different aside from the voltage requirements. We'll begin by focusing on the 24-volt version and what makes it unique. First, to be fair, it's a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one fischertechnik Robotics TXT controller. In this case, the Robotics TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data in a dashboard in the fischertechnik cloud, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates the newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. They also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Unlike any of the previous 24-volt models that we've discussed today, the new 24-volt Training Factory Industry 4.0 also comes with access to a sample program. Now, in this case, the program is in structured text format and was created based upon a Siemens S7 1500 PLC. And this software or this program is available for download on GitHub. Now, of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And these source codes needed are also available for download from GitHub. Now, as with the first of the 24-volt models we're going to look at today, Each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal and both the multi-pin connector, again 34 pins with a grid of 2.54 millimeters, along with PCB terminals with push-in connections for all inputs and outputs. Now again, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website or from the Studica website. If you go right into the product listing for this product, if you go, there should be a section, a tab, where you'll have additional information. You can download this complete PDF, which normally would come with when you purchase it. This way you can download it ahead of time, see exactly what's involved with the model. There are also some additional PDFs that will go over specs of the different motors and photo transistors and other components that are common to these models. And I would say both of those documents are well worth going to our website and downloading. Now, moving right along, in the case of the 9-volt version, the control is facilitated again through the use of 6 robotics TXT controllers. Now, unlike all of the other 9-volt versions that we've looked at previously, say, in this case, these are programmed not using RoboPro, but instead using C++. Again, all the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF that's made for the 9-volt model, which is also available on our website or on the fischertechnik website. So once you've reviewed this and you've done things properly, you should be able to get started pretty quickly. The 9-volt version will require the addition of 3 120-volt power adapters. That's because of the way the controllers are daisy chained. And of course, it requires the ability to access the internet, as does the 24-volt version, along with a tablet or device for accessing the cloud-based dashboard. That should be a given. Dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, again, depending on which version we're talking about. Now, as with the 2 factory simulation models, which we looked at earlier, we do recommend the optional travel case to help protect your model during storage or transport. And that is the Training Factory Industry 4.0 model, again, available in both 9-volt and 24-volt versions. Of course, you might well be wondering how much these models cost. And of course, that's an important point. So let's take a quick review of each option we've just looked at, along with the pricing for each. First off, the vacuum gripper robot in the 24-volt version. These are $974 each. The 9-volt version, again with the TXT controller, is $1,199 each. The automated high bay warehouse in the 24-volt version is $1,099 per unit. The 9-volt version, again with the TXT controller pre-programmed, is $1,319. The multi-processing station with the oven in the 24-volt version requiring PLC is $999 per unit. The 9-volt version with the robotics TXT controller is $1,479. The sorting line with color detection in the 24-volt version, $836 per unit. The 9-volt version with the TXT controller is $1,129. The full factory simulation in the 24-volt version, $4,029. The 9-volt version with the TXT controllers is $5,239. The conveyor belt in the 24-volt version requiring PLC, $226. The 9-volt version, $519. The punching machine with the conveyor belt, 24-volt version, $299 per unit. The 9-volt version, $599 per unit. The 3D 3-axis robot, 24-volt version, $865 each, and in the 9-volt version, $1,169 each, again with the TXT controller pre-programmed. Indexed line with 2 machining stations, 24-volt version, $869 per unit. The 9-volt version is $1,399 per unit. And of course, the Training Factory Industry 4.0 in the 24-volt version. Again, this comes with the programming. Big plus there, $7,896 per unit, and the 9-volt version is $7,560 per unit. Again, that includes all those TXT controllers it's pre-wired to, and there you go. Other items that we've discussed here. The 120-volt power adapters, which are used with the 9-volt models, these are $12.99 each, and the storage and travel case which again is used for either of the two factory simulation models we looked at, the 9-volt or the 24-volt, as well as the two versions of the Training Factory Industry 4.0 model, the IoT version. Either of those, or I should say all four of these models will fit in here very nicely, $1,000 per unit. And again, they should be shipped flat and used flat, not standing on its side like that is, but that was, I think, just an artistic choice. So at this point, I will open it up. If you have any questions, I would ask that you type them in one of the Zoom chat windows. That could be the chat window, could be the question and answer window, whichever one is easier for you to access. If you do have any questions, you can type them right in there. I will wait a second and see if anything comes up. But if not, I'm going to keep talking. So essentially now, if you'd like to take the next step, so whether that would be if you would like to get a full color brochure, if you'd like to get a printed version of the current pricing, if you would like to ask any questions of me directly or our sales reps, if you would like to request a quote, if you would like to speak with your dedicated educational representative, depending on which state you're in, any of these things, you can call us directly. The number here in the US is Studica, 888-561-7521. If it's a general question, a general request for quote, you can email us at info@studica.com. If you do have a question that you would like to ask me directly about anything I've mentioned today, something that you would like me to talk about that perhaps I didn't, or if you have any questions about any of the other fischertechnik models, sets, what have you that we offer, you can email me directly. That is lance.zurek. So that's LANCE.ZUREK at Studica, STUDICA.com. So on that note, I would like to thank you very much for attending today's presentation. I hope you go off and have a great day, and we look forward to hearing from you soon. Take care, and thank you for attending.